All right, we are looking at topic 4, practice part 2, and the picture that pops up is teeny tiny. I'm going to zoom way on in on that thing. All right, we're looking at completing a proof. We've done this before. We just got to select the right thing to fill in these open slots right there on number 3, right there on number 5, and right there on number 6. And I think we can do all of that pretty easily, all right? So let's look at what's going on in number 1 and number 2 to tell us maybe what's going on, to tell us about what's happening in number 3. Now remember, we are trying to prove this right here. We are trying to prove that the two triangles in this picture are congruent to each other. And to do that, you got to have, you have to show that all three sides are congruent and all three angles are congruent. That's the definition of what congruent shapes are. It means all of the sides, all of the corresponding sides, all the corresponding angles are congruent to each other. So when we look at statement number 1, line segment HJ and PG are congruent to each other, and HG and PJ are congruent to each other. That information is given right there at the top of the screen. It is also given when you look at this picture, in that HG and JP both have 1 hash mark, and HJ and GP both have 2 hash marks. Okay? Statement number 2 tells us that GJ and JG are congruent to each other. Well, we look at this picture, and this is something that I tried to emphasize in that last section of notes. Whenever you have a line that cuts through the middle of your shape like that, when you have a line that just goes right through the middle of it, you have to recognize that that is one of your congruent sides. Okay, whether you're looking at this triangle on the left or on the right, you have to recognize that JG and GJ, however you want to call it, that's the same line segment. So of course it is congruent to itself. That's what we call the reflexive property. When you have the same thing on either side of that congruent symbol. Okay, the reflexive property tells us that that is the same. So we have all three sides. Item number 3, angle H is congruent to angle P. Statement number 3. Well, that information is given right up there at the top. Way on back up here at the top. That's given. If you were only looking at the picture, you could see that angle H and angle P both have 1 ring. So obviously, step number 3 is given. All right. Number 4, PJ is parallel to HG. That is also given. Okay. So this is something that I talked about the other day when we were in class. Something to note. Something important. If it tells you that 2 of the lines are parallel, like the line on top and the line on bottom of this shape, if it tells you something is parallel, you need to be on the lookout for parallel lines cut by a transversal. Okay? You need to be on the lookout for those congruent angle pairs, like the alternate interior angles that we talked about when you have parallel lines. Okay? That's actually exactly what's going on right here, because it tells us in the reasoning for number 5, the reason that we're assuming is that alternate interior angles of parallel lines are congruent. Okay? So when we look at this picture, we need to figure out for number 5, what alternate interior angles is it talking about? And when we look at our answer choices, there's really only one pair of angles that it could be talking about, and it's this one right here. Angle JGH and angle GJP. JGH is the one on the top left, right up there. GJP is the one on the bottom right triangle. Okay, so that tells us that those are congruent. Those are alternate interior angles. Whenever you see parallel lines, you need to be on the lookout for alternate interior angles. Okay, so that's what we've got going on for number 5. Number 6, angle GJH and angle JGP. Okay, so when we get through statement number 5, that those 2 angles are congruent, out of the 6 pieces of information that we have to have, remember that we have to have all 3 sides congruent and all 3 angles congruent. That is 6 pieces of information we have to have. When we get through statement number 5, we've got 5 of them. We have all 3 sides, and we have 2 of the angles. By the time we get to number 6, The reason we can conclude that GJH and JGP, the third angle, okay, we already had two of the angles because one of them was given, one of them was alternate interior. The reason we can get the third angle is the theorem that is named after it. It is the third angles theorem. We talked about it on the third day of the topic 4 notes. The third angles theorem tells us that if two angles are congruent between your triangles, then the third angle has to also be congruent. That's the only possible way it could work. So that's what we've got. We've got given, we've got the two angles congruent, and we've got the third angles theorem for question number 1. Going on now to question number 2. Wow, that got really messed up in the formatting here. Okay, let me see if I can come over here and rewrite this in the notes app. All right, this tells us that figure. This is question number 2. ABCD is congruent to FGHJ. All right. It's asking you to find angle B. Find angle B if angle B is 3y and angle G is, what did it say? Y plus 50. So this goes back actually to a couple of those days of notes from the beginning of this section. This goes back actually to back when you learned about corresponding parts of shapes. And when you're talking about corresponding parts between two shapes, the order that you're going in matters. So when we look at these two figures, ABCD and FGHJ, we don't know anything about them other than they are congruent to each other. But that is enough to tell us that if B and G are corresponding, then those two angles are going to be exactly the same size. And the reason we know that is because they're congruent. It told us at the beginning that those two things are congruent to each other. So what we can do is we can say that 3y equals y plus 50. And if 3y equals y plus 50, that's a pretty easy equation to solve. We got to move this y over. That all goes away. We've got 2y equals 50 and y equals 25. Now here's the question. When we're asking this question, does the question care what y is equal to? The answer is no. This question isn't asking about y. This question is asking, what is angle B? Angle B is 3y. We have to take this y equals 25 and plug it in right there. So angle B is going to be 3 times 25, which is 75. And that's the answer we're going to select. All right, this one is a very, very similar question. This time it's asking about angle C and angle H. So we look again at our ABCD and FGHJ. We look again at ABCD and FGHJ, and we see that C and H are again corresponding items. So this time we're dealing with angle C, and it tells us what angle C and H are. It says that angle C is 5z plus 20, and angle H is 6z plus 10. Again, the process is exactly the same. We take those two things and we set them equal to each other because C and H are corresponding parts. Those angles are going to be equal to each other if the figures are congruent. So 5z plus 20 equals 6z plus 10. Just do some quick math, move the 5z over, and then we subtract 10. So we get that z equals 10. Does it matter what z is equal to? No, because the question is asking, find the measure of angle C. So if we're finding the measure of angle C, here's what that looks like. Finding the measure of angle C, all we got to do is plug in this right here into that expression up here. So 5z plus 20 turns into 5 times 10 plus 20, which is 70. And that's what our answer is going to be. All right, we got another proof question. AD and BE bisect each other. That's given up at the top. Tells us that AB and DE are the same length. That's marked with the hash marks right there. It tells us that angle A and angle D are the same. That's marked with the rings on those angles. All right? So we have to fill in the reasons for why are these triangles congruent. Okay, first of all, we need to know what's going on. All of that information that's given at the beginning, that's great. That's fabulous information. But when we get to statement number 2, AC is congruent to CD, how do we know that's true? And the answer is this. It's all in that word bisect. That word bisect means cut in half. Okay, cut into 2 equal pieces. So if AD and BE bisect each other, that means they cut each other in half. They meet in the middle of both of those lines. So that means AC and CD are the same in that picture. That means BC and CE are the same in that picture. So when we're looking at number 2, the reason we know that's true is because they're bisectors. That's the definition. That's what bisecting means. It means it cuts it in half where the 2 pieces are the same size. Next, we're looking at angle ACB and angle DCE, and it says those 2 are congruent. Well, how do we know they're congruent? This is a picture very similar to the ones that we've looked at before, where it's something that you have to recognize. Okay, and this one is a little, it's something that might catch you off guard. Okay, it's something you have to be on the lookout for, because in the middle of this picture right here, right around where point C is, right in the middle of the picture, you have what's called vertical angles. Okay, it's the angles that are directly across from each other when 2 lines cross and make an X. Okay, it's two angles that are directly across from each other on opposite sides of the X, and vertical angles are never going to be marked in the diagram on a picture. They're never going to be marked as congruent. You have to recognize that those are congruent. And that's what's going on in statement number 3. The reason that works is because they are vertical angles. The next thing we're looking at in statement number 4, angle B and angle E. Okay, well, it says if we are given that one of the angles is congruent, statement number 3 told us that vertical angles are congruent. How do we know that the third angle is congruent? Just like we talked about a minute ago. The third angle theorem is named after that exact situation. Okay? The third angle theorem says that if you've got two congruent angles between your triangles, the third one has to also be congruent. And that's how it goes. All right? So number 5, by the time we get through steps 1 through 4, we have all 6 pieces of information. Okay? We were given, from step 1 and 2, we've got all 3 of the sides and one of the angles. Step 3 gave us the second angle, and step 4 was the third angle. Okay, that's all 6 pieces of information, and that's just the definition of what congruence is. All right? Congruent triangles means that we've got all of the same sides, we've got all of the same angles between the 2 triangles. That means they're congruent. That's just the definition of what it is. So we move on down now to the next problem. And it's asking, is the information in this picture enough to tell us that the figures are congruent? All right, so we have to look very carefully at what information we have right here. First off, we have that angle T and angle Q are right angles, and that's great. That's good stuff. We also have in the middle of this picture, one of those situations that we have to be on the lookout for. We got vertical angles. Right around point R, we've got two vertical angles. The third angles theorem, even if we go past that, the third angles theorem says that S and P have to also be congruent to each other. But here's the deal. Do we know anything about these sides? If we're trying to prove that things are congruent, we have to know that all of the angles and all of the sides are congruent. It's not just the angles. It's not just the sides necessarily. It's all of those things. We don't have any information about the sides of these triangles. So we're going to say, no, that is not enough to conclude that those figures are congruent. Very similar question on number 6. When we look at these triangles on number 6, I see that AC and HF both have 1 hash mark, so they're congruent. AB and GF both have 3 hash marks, they're congruent. CB and HG both have 2 hash marks, they're congruent. So we got all 3 sides. Angle B and angle G both have 1 ring. Angle H and angle C both have 2 rings. That means those are congruent. The third angles theorem, remember that third angles theorem. If 2 of your angles are congruent, the third one has to also be congruent. So that means angle A and angle F are also congruent. All right, so that means, yes, we do have enough information. We've got all 3 sides, we've got all 3 angles, and that's good enough to do it. Question number 7. We've got some important information up in the given section up here. Okay, this is important. It tells us that US and MC, that's talking about the line on top and the line on bottom of this shape, are parallel to each other. That is very important information right there. Okay, because that tells us whenever we have parallel lines, we need to be on the lookout for any of those alternate interior angles that might be equal to each other. And that is actually exactly the situation that we have right here. Okay, the exact situation that we have is that the angle up in the top right here, this 32, and this angle down here, 8x minus 12, are alternate interior angles. Alternate interior angles are congruent to each other. When you have parallel lines set up like that, your alternate interiors are congruent. So that means we can set up an equation. That's exactly what I'm going to do over here. We can set up an equation that says this. We can set up that 8x minus 12, that angle down the bottom, equals 32, that angle up at the top. And I can solve that equation and find what x is pretty easily. All right, so if x equals 5.5, well, I guess that actually answers the question that we've got right here on number 7, right? X equals 5.5. That's exactly what we were looking for. Question number 8, though, is where we got to apply that knowledge. Okay, question number 8 says, has the exact same picture, the exact same given information, and it is asking us to find what is going on with angle S. Now, I will say this. Up in the given information, angle S is the exact same as angle C. That's very helpful information. So that tells us if we can find what C is, that will be our same answer that we're looking for. All right? So we have to remember a couple of things about triangles. First of all, in this specific picture, we have to remember that x equals 5.5. That's what we just found. Excuse me. That's what we just found way back over here. X equals 5.5. So if we're plugging in x equals 5.5, we're going to do that right here. 4x plus 36. 4 times 5.5 plus 36 becomes 58. If we're doing that on this one down over here, we already know that this angle down here, this 8x minus 12, that's equal to 32. Okay, that's that 32, and that's the 58. That's the two angles that are labeled on the triangle down on bottom. That's 58, and that's 32. Well, we have to remember that inside of every triangle, all of the angles always add up to exactly 180 degrees. It doesn't matter how long your sides are. It doesn't matter what the triangle looks like. If it has 3 sides and 3 corners, like a triangle, it adds up to 180 degrees. Okay, so we take that information that we already have. We take the 58 and we take the 32 and we add those together, and that's 90 degrees. Well, if we're trying to figure out what that last angle is, it's going to be 180 minus 90. That tells us angle C down here is 90 degrees. Okay, so what does that mean for our question? We got to look back up at our given information. Angle S is congruent to angle C. And that word congruent, we've said it time and time again. Congruent means the same. So if angle C is 90 degrees, then so is angle S. And that's the answer that we're looking for, 90 degrees. Now, I want to point this out to you. This picture right here, angle C and angle S do not look like right angles. Okay? They do not at all look like they would measure 90 degrees. But does that matter? No. That absolutely does not matter, okay? Just because the picture doesn't look like it doesn't mean your math is wrong, okay? You cannot go by what the picture looks like. You have to go with what the math says. This is something I've been trying to emphasize all year long. It is not a matter of what the picture looks like. We don't care what the picture looks like. We care what the math tells us. And the math tells us that angle C and angle S are 90 degrees. So that's what we're going to go with. All right, that is the end of topic 4, practice number 2. The next video will be practice number 3. We'll be done.